Guys, this is Mr. Gucci here to help walk you through this day's homework, which is the 3.2 worksheet, Atomic Mass. Okay, well, first things first, guys, on all these kind of worksheets, you got to put your name first. All right, I'm David Gucci. Hello, everyone. And my student ID. All right, you got to put yours. I'm going to put my fake student ID, 1, 2, 3, 4, 5, 6, right? And that'll generate random values for this entire worksheet. Take a look below. Ready? Bam, the number's changed, all right? If you missed it, rewind it, all right? So all of these are atomic mass problems, which are pretty straightforward. Remember, the atomic mass is the weighted average mass, all right? The weighted average of all the different isotopes. So for example, let's take a look at number 1 here. What is the atomic mass or weighted average mass of potassium, atoms, given that 32% have a mass of 39, they're potassium 39, and 68% have a mass of 41, they're potassium 41. So this average, we can tell, is going to be somewhere between 39 and 41. It's probably going to be a bit closer to 41 because more of potassium is this potassium 41 isotope. So here is the formula for it. It's pretty simple. Okay, the formula is this. The atomic mass equals, and I'm going to actually put this up here so it's a bit out of the way. The atomic mass equals the mass of the first isotope times its percent, plus the mass of the second isotope times its percent, plus the mass of the third isotope times its percent, and so forth, etc., 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 however many isotopes there are. If there's only 2 isotopes, then you only got 2. If there's 5 isotopes, you got to do this 5 times, and then you add it all together. Now, this is something that, while I need to see work, this work can be easily typed up. I don't think I need to see it on a separate sheet. You can do your work right here in this work column right here. Okay, so let's take a look, all right? Atomic mass equals the mass of the first isotope, all right, potassium 39. Okay, so that's a mass of 39 AMU, times, what is its percent? Its percent is 68%. Okay, then I'm going to add to that the mass of its second isotope. Oh, wait a second. Nope, I messed up. Potassium 39 is 32%. All right, I got to read carefully. All right, it's potassium 41, that is 68%. So 41 times 68%. Okay, what does that equal? Well, I'm going to plug it into my calculator here. Okay, I'm going to plug it in. So 39 times 32%, and I'm going to use the percent button on my calculator, or you could just do 0.32. So that equals 12.48 plus 41 times 68%. 41 times 68%, which is 27.88. What does that equal? Now remember, this answer, because it's an average, should be somewhere between the low and the high number. It should be somewhere between 39 and 41, and it should be closer to 41 because you have a higher percentage of 41. So when I add these guys together, okay, 12.48 plus 27.88, I get 40.36. Great. All right. So 40.36, is that good? That's correct. And the units are AMU. In fact, the units are going to be AMU across the board here because you're doing atomic mass units with all of these. Okay, so there we go. I included the work. I did not need to attach a separate sheet. If you would prefer to attach a separate sheet, though, that is okay. All right, on to the next problem, okay? What is the atomic mass of neon given that 78% is neon 20 and 22% is neon 21? Okay, so listen. I know that this atomic mass is going to be somewhere between 20 and 21. And it's probably going to be closer to 20 because a higher percentage of this is neon 20. So here I go. Atomic mass equals, all right, neon 20, mass of 20, times 78%, plus neon 21, which 22% is that. Okay, so what is that? So 20 times 78%. This is 15.6 plus 21 times 22%. 21 times 22%. 4.68. Add those two together. 15.6 plus 4.68. And I get 20.22. All right? 20.22. Correct AMU. Once again, the answer was somewhere between 20 and 21, because those were the low and the high atomic masses, or the low and the high mass numbers, and it was closest to whatever I had the highest percentage of, okay? Let's take a look at number 3 right now, okay? What is the atomic mass of gold given the following atomic masses and percent abundances? 82.3% of gold is the gold 197 isotope. That is a gold made out of 79 protons, because gold is element 79, and 118 neutrons. Okay, that is the gold 197 isotope. 82.3% is that. 10.4% is gold 198, and 7.3% is gold 199. Now, again, my answer needs to be between the low and the high masses. So it's going to be somewhere between 197 and 199. And it's probably going to be closer to 197 because such a high percentage of this gold is gold 197. So atomic mass, here we go. That's equal to the mass of the first isotope, 197, times 82.3%, plus the mass of the second isotope, 198, times 10.4%, plus the mass of the third isotope, 199, times 7.3%. Okay? And what does that equal? Well, let's see here. 197 times 82.3%. All right, that's 162.131 plus 198 times 10.4%. That's 20.592. Plus the last one, which is 199 times 7.3%. Now listen, guys, this is where people often mess up. 7.3% is the same as 0.073. It's not 0.73, that's 73%. It's 0.073, that's 7.3%. Or you could just use the percent value in the calculator or on a search bar, okay? So that is 14.527. Okay, add them all up. 162.131 plus 20.592, okay, plus 14.527, we get an atomic mass of 197.25. All right. Keep in mind, 7.25, let's see if it's correct. Yes, AMU. Once again, our number was between 197 and 199, and it was closest to 197 because we had the highest percentage of 197. Okay, let's try number 11. Okay, I got class in like 8 minutes. I'm just going to go on this video as long as I need to work on these problems with you. Okay, so what is the atomic mass of krypton given the following atomic masses and percent abundances? So this is a pretty even split. So 45.5% is krypton 85. All right, 30.3% is krypton 87, and 24.2% is krypton 89. Okay, so these are the different isotopes of krypton. So here we go. Atomic mass equals the mass of the first one, 85, times its percent, 0.5%, plus the mass of the second one, 87 AMU, times its percent, 30.3%, plus the mass of its third isotope, 89 AMU, times its percent, 24.2. And what does that equal? Okay, let's see here. 85 times 45.5 plus 87 times, gotta make sure I had that percent in there, percent, plus 87 times 30.3% plus 89 times 24.2%, I get 86.57. Correct. AMU. Now, guys, if you end up with a number that is not between the lowest and highest masses, then something is wrong. And you have to go back and double check your calculation. The most common mistakes are forgetting to include a percent sign. So instead of, for example, multiplying Krypton 89 by 24.2%, you multiply it by 24.2, and you end up with something 100 times bigger than you should. Okay, that's the most common mistake. Other common mistake is if you have a percentage that's like only in the ones place, like 7.3% or 1% or 5%. Remember, 5% is not 0.50. It's 0.05. Okay? You got to bounce that decimal place over or just use the percent button on your calculator. All right, let's try and get these last two before my class begins. What is the atomic mass of phosphorus given the following atomic masses in percent abundances? So 38% is phosphorus 30, 18.6% is phosphorus 31, and 43.4% is phosphorus 32. So I'm going to do the work right here. Again, if you'd rather do this on a sheet of paper and then attach a picture, that's also fine with me. I just think it's easier, on a computer at least, to type. Maybe not on an iPad or something, but here we go. So the first one has a mass of 30 AMU, and it's 38%. Plus the second one, which has a mass of 31, and it is 18.6%. And lastly, the third one has a mass of 32, and it has a percent of 43.4%. Okay? So, plug that into the old calculator. All right, 30 times 38% plus 31 times 18.6% plus 32 times 42.4%. Now, before I press enter, remember, we know in our head that the answer has to be between the low and high masses. It has to be between 30 and 32. And because it's a pretty even split between the percentages, it's probably going to be somewhere in the middle. So I'm expecting an answer somewhere near 31. And I press enter and I get 30.734. Let's see if this is right. All right. 30.734. That is incorrect. So somewhere along the way, I messed this up. Okay, somewhere along the way, I messed this up. Let's see where I might have gone wrong. So 30 times 38%. Okay, I did that. 31 times 18.6%, right? Let's see here. So what is going on here? Time to go a bit more in depth. Okay, let's double check this. So let's see here. 30 times 38%. So this should be, the first one is 11.4. All right, plus 31 times 18.6%. 5.766. Plus the last one, which is 32 times 42.4%. And I got 13.568. Okay, let's see here. So Add these all together. Double check. All right, 11.4 plus 5.766 plus 13.568. I got the same thing again. So is my answer checker incorrect? Is my answer checker incorrect? It might be. It might be, but it seems like it should be. Guys, I'm going to take a look at this, all right? And I will get back to you. If you're having trouble with 12, with number 4, hold off on it, all right? Take a stab. I saw people had gotten it right before. Maybe y'all are getting things right that I'm just messing up for some reason that I just cannot understand, okay? Anyways, good luck, people, and I'll see you in class soon.